Welcome to Beyond the Qubit. Today I'm joined by Amir Naveh, co-founder and chief product officer of Classiq, the world's most funded independent quantum software company. From building satellites in Israel's defense industry to raising $170 million for Classiq, Amir shares why scalable software is the real bottleneck in quantum and how his team is creating the Microsoft moment for this industry. Before we start with the podcast, I have an important disclaimer. I do not represent any company here and do the podcast under my own title. Let's get started. I think you're in a very interesting position in the value chain. If you are one of the standards in software, then you will also see new starting companies that start to use your software to create new products that will impact society.
Yes, exactly.
And you will be one of the first seeing them growing the amount of users. So I think with that you can also, that gives you a lot of visibility into end demand.
Yeah. That's one of the main advantages we have in today's market already today, but for sure as it grows, is that we have first line visibility into what customers are doing, what they need, what use cases they're working on, what applications, what are the resources needed. If you're a quantum hardware or quantum cloud provider, you get you process the program, but you don't get this first line. Having the fact that we have a support team that is working with dozens of enterprise customers today, that is a huge advantage for us. Our knowledge and engagement and friction with the market, it's something that other companies just don't have. And as you mentioned, as it grows, as it becomes one day impactful in terms of real business value, then in this position, it's very valuable, for sure.
When we talk about the role of Classiq in the quantum stack, and where does Classiq sit in the quantum software stack?
Yeah. So I'll try to map it out a little bit. So at the very low end of the stack is maybe companies like almost hardware companies like quantum machines, which are actually doing the control, which is software like at the pulse level. And also companies like, for example, Kedma and Q Control. What these companies are doing very, very close to the hardware, trying to characterize the noise levels, for example, on the qubits, and then run protocols that effectively reduce the noise. This is kind of in the software stack. Of course, I can begin with the hardware, but if we're talking about the software stack, this is, I would say, for sure. On the highest part, there are companies like, for example, Algorithmic, Phasecraft, which are saying, look, we build algorithms. We don't have any product, software, technology. We don't do that. We just have very strong researchers which will take the problems, quantum chemistry, quantum simulation, stuff like this, and really go into the guts of the problem, really understand the quantum chemistry problem and how it works, and then do the very hard science of mapping this into, something a quantum computer can handle. So this is at the very high end of the stack, like I'd say the researchers, maybe the algorithm builders. And Classiq is essentially the bridge between these two parts of the stack. So what we take as input is a description of the quantum program. So someone needs to understand what they're trying to do. A researcher or a domain expert, someone who is able to describe the problem. And our output is instructions for the hardware. But we don't do, for example, this error characterization. That is not our focus. So we work with these, with IBM, with Kedma, with Q Control, with others to do this, like, for example, error mitigation techniques or stuff like this to make the hardware more efficient. But this is not our core expertise. So we take from the problem description to an optimized quantum program that actually runs on the hardware. And then we also have all of the integrations set in place. So if you actually want to run it on Quantinuum, IBM, IonQ, Alice and Bob, Pascal, Rigetti, Google devices, like all of the available hardware today, you can just do it with one click. Now, of course, we're not developing the hardware. Also, simulators like NVIDIA simulators and Intel simulators, all of this is one click through the platform. It's for you as a user, are maybe we are this part in the stack that is on top of us. It's the users, the developers, the algorithm experts, and on the bottom, it's the hardware and everything needed in order to make the hardware effective.
And how do you do that? So how is it possible that Classiq is compatible with superconducting, but also with maybe ion trapped or with cold atom or with photonics quantum computers?
So one good thing that happened, because quantum was established in the academia before it came into kind of the company labs, there is a standard for quantum for describing the hardware descriptions, right? Every single hardware implements a Hadamard gate. Every single hardware implements either a control Z or a control X or a control phase gate. Every hardware implements an X gate, and so all of these, and you can build any program from these basic building blocks of gates. So IonQ is very different, or ion traps are very different from superconducting, but you need the same gate instructions. Now, of course, the program will be very different, will be optimized very different for a ion computer which works slowly but is fully connected compared to a superconducting device which is very fast but sparsely connected, and different errors, etc. So, of course, it's going to be a different program. But this is something our compiler knows how to take into account. I have a program. Let's say it has something called a multi-control X gate. This multi-control X gate can have many different implementations. I will implement it optimally with knowledge of what the hardware that is underneath. But this is part of the algorithm that we've built to compile these quantum programs. And then all you need to do is give me the modality and the specifications, and the program fits this modality and actually is even optimized for it.
Does it also include photonics quantum computing? Because they first do the hard part, and I'm not sure if they also
in theory,
work with
yes.
the same.
In theory, yes. If you want to run on our platform on a photonics computer, I'm sorry to say you cannot do it, because the only players that are really developing photonic quantum computers today are PsiQuantum and Xanadu, and also Quantum Source in Israel. And all of these just don't have any APIs to work with. So unfortunately, they don't expose it, so we cannot access it. We've discussed with these companies. I hope one day we will be able to create this integration. It's not a very hard effort on our part, and it shouldn't be on their part. It's just a question of do they want to expose it or not. But it's no problem. You map a gate circuit into a measurement-based protocol and vice versa. They have you can convert from one to another. It's the same mathematics.
Is abstraction critical for unlocking real-world quantum applications?
Good. So maybe I'll give an example. It was just accepted to the IEEE conference 2 days ago, so I can give that example on doing option pricing. We were working with an Italian bank in Intesa Sanpaolo on this. So it's a good example. You want to do derivative pricing, for example, right? You have some asset which is dependent on other assets and correlated to them, and the price in the end is determined on the path of the prices of the underlying assets. This is the kind of basic description of how to price derivatives. And of course, because all of these things are correlated and because they have kind of different distributions, and so when the number of assets and number of time steps is large, it's untraceable computationally in classical methods. What you do is Monte Carlo. And you can speed up Monte Carlo methods with quantum computers. So all of this is known. This is not something that is specific to Classiq. But then you go into the real problem and you say, here's a rainbow option. This is how the price, the strike price actually works. Here is the equation that tells you how the derivative is priced based on the underlying assets. And now you need to take this equation and this dynamics of how the asset behaves and map them into the quantum algorithm. So it's complex arithmetic, it's complex logic, You need some way to build it, and this is exactly the same as if I were to tell you, here is how you sort a large array. Now I tell you, here is an Intel processor, it has 1 billion transistors, or here is many NAND gates. You can use as many NAND gates as you want. Build this sorting algorithm for me. So you would have no chance. You cannot manually build a merge sort algorithm in a scalable way using just transistors. This is what the classical software stack was built in order to solve. You have many different steps of abstraction in order that you can just forget about how it maps into the NAND gates and write your logic. And so this is a good example. It's not some radical new problem. The problem is known. It's pricing derivatives. I can tell you the mathematics of the problem, but mapping this into a quantum program that actually works, I would tell you, do this, just put in all of the quantum gates and tell the hardware what to do. You can work on this for 1 year and it would still not be optimal. It's not something that you can do manually. And without it becomes...
How does Classiq do this? How do you map the abstraction? And how do you map the problems?
We have a language called a quantum, it's called QMod. It's short for quantum modeling language. And in this language, for example, you write just the arithmetic expression. You write A plus B times C equals 7, for example. And then underneath this, what happens is we have a parser for this language that maps it into the logic. So from this language, we obtain some kind of mapping of what is the logical flow of the program. In this logical flow, we are able to now map this into a sort of a constraint satisfaction problem, a discrete optimization problem where you can control many different resources. It's just these are your constraints. This is your domains, and this is what you're trying to optimize. Optimization problems, that's not a new domain. So we have a lot of experts in the company in solving classical optimization problems that take this now abstract mathematical problem of just solving the optimization problem and solve it fast and good. And this is something that a computer does orders of magnitude better than a person. And the output is the assignments for each of the variables which map to an instantiation of the solution for the optimization problem, which is, in the end, it's a quantum program. So it's kind of, you take the description, you map it into a logical formulation, you create this logical formulation into an optimization problem, you solve the optimization problem, and the solution is your quantum program. So this is kind of, but all of this, I mean, it's a great question. I'm happy you asked it. But all of this is transparent for the user. For the user, they just need to write the program, and what they get as the output is the optimal implementation. And all of this is kind of black box for them. Okay, Classiq is doing smart things under the hood.
And the optimization, you said that solving the logical problems, is that done on classical computers? Because you said the experts are known, are used to work on with the classical methods, or is it natively written for quantum, or is it a hybrid?
The optimization problem, it's no longer has any relation to quantum. The optimization problem is just now an optimization problem. How do you solve an optimization problem? Maybe one day with quantum computers. I hope so. But today, a quantum computer will not help you in solving an optimization problem in production, in scale. That is what we are waiting for. So today, obviously, it's running on GPUs, some AI methods as well. I mean, we have a lot of heuristics involved. A lot of smart people have worked for several years on building this solution to the optimization problem in the end.
So where does the quantum come in? If the optimization is done on...
So again, I will try to keep it short and simple. I'm a quantum programmer. I have a quantum program. No, for sure. It's went a little bit more into the details, kind of losing the big picture. So
I love the details. I always want to understand the details.
No, it's good. It's good that you're asking. I will make it clear. Quantum programmer, he writes quantum. Our output, he writes a quantum description, right? He writes the quantum program in the way that is meaningful for them. The output is instructions to the hardware that are concrete, and I can send now to an IBM machine or to an IonQ machine that runs. So So everything here is quantum. Quantum programmer gets a quantum program, can run it on an IBM machine. Now you're asking, how do we do it? How do we create
Yes.
from a description to a concrete quantum program? And this conversion is classical. This conversion is using classical computers, but the problem stays quantum, and it's running on a quantum computer. It's just that doing the smart stuff, for this, we use classical computers in the middle to automate the way quantum computers, to automate and build better quantum programs, you need classical computers. This is maybe the essence. But it doesn't make the program classical. It's just that I can reduce the resources using GPUs and AI and things like this. And one day, maybe quantum computers will also be used to compile these programs efficiently, but it's not there today, and we give value already today without needing the quantum computers to solve this problem.
The thing that I was wondering is AI is also used a lot for programming language and for programming. How could AI help you to build your libraries? Is there a role for that? Do you work with AI?
I love it. I love it. So stay tuned. I hope we have a debate now in the product team if it's going to take 2 weeks or 3 months. But hopefully sooner than later you will see what we've been building exactly in that space, which is generally your first quantum code assistant that really works. And the reason we can create it and others have a hard time is because we have a huge library that is already built of algorithms and applications, which is up to date. And so if you train on this library an MCP server, for example, and you do some refinements, which we are now doing, then you have it's kind of like a copilot, but for quantum, which actually works. So you can say, solve this optimization problem. You will actually get a real quantum code that does it.
One of my key beliefs in investing is the tectonic shifts in compute. And I believe that quantum is the next tectonic shift. In the PC era, software was dominated by Microsoft and the hardware was dominated by Intel. In mobile, Apple dominated both software and hardware. And for AI, for parallel compute, the latest tectonic shift in compute, NVIDIA controls both the software and the hardware. What is your view? Will the winners in quantum control both software and hardware, so will be integrated like Quantinuum or IBM? Or will the hardware and software be software?
Ooh, that's a challenging one. So of course I don't know. I honestly don't know. I think there are good claims for any of these paths, and I also think for all of the examples that you mentioned, no one could know 10 years in advance. It's also, I don't think it's something that is fundamental for the market. I think, for example, one of the reasons that Apple dominated is because they had a visionary leader and extremely strong execution, and they just created products that customers love. Apple were just a hardware, just a software company, and still created products that customers love with a vision, they would have a decent chance. And if Apple were led by other people, so maybe it would have been different in the smartphone. So I don't know if it's something that is intrinsic to the the era or to the type of compute, or it's just because some companies are better than others for many different reasons, and this is how they come to dominate. So I really don't know. I don't know what will happen in quantum. I don't know in the past if it had to be this way as you described. I will say this. I think even if there is one dominant player, let's take IBM, for example. Let's assume IBM will dominate. Full stack, hardware and software. I don't think this is game over for the rest of the quantum market. NVIDIA dominates, but AMD is still $1 trillion company and has high hopes. And so is Intel. They're still involved in the game. And so is, there are many $100 billion companies that are contenders just doing some parts of either the chip design process or the computational parts, which all have a place. So, of course, there is one dominant leader. But in all of these examples which you gave, the contenders are also, they have a place. It's not that the competition is over. And in the competition space, I think for all of the examples you said as well, there is room for both. There is room for the pure play software, for the pure play hardware, for the fully integrated stack. So as maybe someone who is representing a software pure play, I'm saying, I think there is a chance that it will play out like this, that it will be like Microsoft, which was able to dominate the software even though it was not building the hardware. Maybe. But even if it's something that is, let's say, more close to how AI is now working out, where the software and the hardware are coupled together in some sense, still there is a huge place for a software vendor that actually gives value, that is able to actually optimize, reduce resources, make things more efficient, more easier and more efficient for the customers. So this is my view, that kind of we are all on the same side of hoping quantum comes here sooner rather than later. And in this game, yes, there will probably be one or two dominant players. We will do our best to be one of them. But I think also in the turnout that there is room for others.
How do you think those developments impact Classiq?
The development of, what do you mean?
Of horizontal or vertical integration.
So, I mean, for us, obviously there is an opportunity with the hardware players that are not so much advancing their software stack, which is most of them. So IBM and Quantinuum are actually the outliers, which have very, very strong quantum teams. But I'd say for almost all of the hardware players, they are not investing in a very strong software stack for obvious reasons, because you need focus. And I think for us, it's an opportunity to do joint business and to be the ones that are actually creating the ability to run on their machines. We have quite a lot of partnerships and business agreements with these hardware providers. Also like joint submissions to government offers or grants or tenders like this. So this is obviously an opportunity. And I think, yeah, obviously it's a challenge for us. For example, IBM, on one hand, we also support Qiskit and Kazem, and we support running on IBM machines, and we are in good relationship. But on the other hand, I would definitely say it's competition. Also, Quantinuum, the software part at least, yeah, it's competition, because in the end, everyone will use one dominant software framework. If they are using the IBM framework and not ours, that is not the place where we want to be. We need to be sure we provide value to these users. And so it's if we're competing if I mentioned our mission is to make sure everyone that creates a quantum program is doing it with Classiq, then also on this same breath, I can say if someone is creating quantum programs without Classiq, this is where I am focusing my competition eyes. So this is kind of, I think, how this dynamic is working out.
Thank you. Maybe I think we need to talk about it a little bit more. What is the difference between Classiq and Qiskit? We touched a little bit on it, but can you summarize it maybe?
Yeah, I'll go back to the example of the option pricing. If you wanted to create the option pricing example with Qiskit, it would take you many months and you would not be able to do it with the same resources. You would need much, much more resources in order to do it. Why? Because in Qiskit, you are beginning you write explicitly the implementation. You begin with the implementation. And with Classiq, you describe your algorithm. And the difference is huge, and it gets bigger as the quantum programs get more complex. So if I just want to do a simple Bell state on 2 qubits, there is no difference. But if I want to actually do option pricing, which has some complex logic within it, and I want to do it directly in Qiskit, I will be doing the parallel of putting these NAND gates and working with the transistors in order to create the complex algorithm. I'm not joking at all. It's funny, but it's true. This is really the case. In this algorithm, there is 200 of these MCX gates, and each of these MCX.
And I'm not laughing because I think it's funny. I'm laughing because I'm excited.
And I think, for sure. It's for me, it's a little bit funny because the majority of users today are still working with Qiskit. And I think there is a lot of good things to say about them, but it's not the way to create scalable quantum programs. You just cannot do it. And this is still, even the option pricing example, it's still a small one. It's still an example just to showcase a concept. But if you're trying to build something real, You're trying to actually build a new pharmaceutical drug and trying to do an affinity binding use case in a scalable way. It's 0 and 1. You cannot do it with Qiskit, and you can do it with Classiq, and that is the difference. The difference is that Classiq is built for creating the programs in a scalable way, and the abstraction is real, and Qiskit enables you to work with maybe today's hardware. But when the hardware advances, the fundamental way that the software is built, it's not built for scale. It doesn't give you a way to abstract your logic away from the implementation.
Thank you, Amir. Can you walk us through how Classiq is building the ecosystem? I think within software, the ecosystem is very important. So how do you build the ecosystem of users and subscribers? And you mentioned, okay, we go to universities. Yeah,
yes.
Could you walk?
For sure. So the first part, which is maybe a necessary condition, it's not sufficient, but it's important, is that we really are able to give value to these users. We have, as I mentioned, it's not only the better performance, it's also the part that the integrations with all the hardware and simulators are just working one click. It's the fact that we have a hosted environment where you don't need to install anything, you can just work in Python, pre-installed for you. All of the application libraries up to date. You can upload any example, you can work on it, you can modify it, you can save it in your workspace. Everything, it's all for free. All for free and very it's easy, right? It's very low barriers of entry. So this is something, without this, it would be a hard challenge to bring in users. But with this, it's the value is pretty clear. And then it's, a lot of the efforts is, I would say, branding or marketing efforts in a sense, not in the I would say not in the bad way of marketing, like putting paid campaigns. In terms of exposing this, making sure that people are more aware and have some experience. So how do we do that? One way is enter curriculums of courses for the quantum information courses and quantum algorithm courses in many universities. And then they are using Classiq as their platform for education, and this brings the students in. Second is there are many community events like hackathons and meetups and conferences, and then we make sure that we present everything over there. And we also have a large...
Can you maybe explain or quantify the amount of students that work with Classiq? So how did that evolve the last 3 years?
Yeah.
Is it like hundreds? Is it like thousands or or how are you scaling that, the amount of university students working with Classiq?
It's hundreds of universities today, and the number in each university somewhere between dozens to hundreds of users typically. And yeah, everything here is in the past 2 years. 2 years ago, we started this effort of building a community. So these are the typical numbers. For me, the important part here, the bottleneck, if I'll say today, the thing that is most challenging for me is to keep the users recurrent users, right? Because a lot of the people, right, okay, so you did a quantum course, great, you've used Classiq, you loved it, but now you have nothing to do with quantum in your day-to-day life, so we will not see you anymore using our platform. Now, I cannot change what you do in life. If you finished your first degree and now you are going to work in AI and don't have time for quantum anymore, fair enough. I'm not trying to chase you into quantum, but I do want to better understand the market and the number of people that are using quantum in their day-to-day life. The researchers that are there for the longer term and the people that are there, not for one course or one semester, but for years, and to be able to target this market a little bit more and make sure that I'm growing there. In that place, I think there is still a large gap for us. I don't think we are still there in a place where we are scalably growing and seeing it, organically increasing month over month. I also don't know how large this market is. I don't know how many people day to day are working with quantum. I have my estimates, but I haven't created something I'm comfortable with yet, and I haven't seen any analysis that I can really trust on how many people are potential recurring users in academia for quantum, for creating quantum software? I don't know the answer. And this is a really interesting question for me. If you find out the answer, I would love to know it.
I have some ideas. Maybe after the call I can walk you through. I've got two more questions. My first question is, what do you want to achieve on a 10-year view?
On a 10-year view? That's easy.
Yes.
That's easy. On a 10-year view, I want to be, I hope it doesn't sound like too ambitious, I want to be the Microsoft of quantum. That's what I want to be in 10 years from now. I want every single person that creates quantum programs to do it with Classiq, and I also want quantum computers to give real value, and so quantum computers are giving value to the world, and it's done through Classiq software. Simple as that. 10 years from now, someone said, I don't remember who, that 1 year is too short, and 10 years is people underestimate what can be done in 10 years. For 10 years, I dream big. I think in 10 years, the dream can happen.
And what are your must-win battles to reach that?
One is not up to us. One is the hardware. I do hope that in 10 years from now, the hardware will be in a stage that is giving value. That's not up to us, but I hope it happens. Otherwise, we will not be where I want us to be. But that's not up to us. I can't do anything. Another thing is making sure that we are leading in technology. This is the case today, but today things are at the beginning. Google and Microsoft and NVIDIA and others will wake up. And we are still a small company. And this is a battle. I mean, we are prepared for it for day one, but when it will happen, it will be a fierce one, right? OpenAI having the best model today, it's a fantastic achievement for them, right? They were built one first, but the fact that still they are dominant, or one of the dominant players, that's up to pure technology, real execution power. So that's a second one. And third is business. There is this, in classical computing history, it's kind of like, why was Microsoft the standard in operating systems? Not necessarily because they were the best one. I don't know if Linux is better or worse than Windows. I know a lot of people that would say Linux is better. But in the end, Linux is not the standard. Windows, at least, was the standard. Because they did a lot of good things that is not only the best product. They did a lot of good deals. They were there early in the ecosystem. They had fantastic engagement with users in the very early days, deals with IBM that changed. So this is like the way we do business in the next 2 years and build the community and build the customer base in these early days. That's critical. And hardware not up to us. 2, technology up to us. 3, business up to us. So now we focus on business and technology and hope the hardware companies do their job.
My last question is, can you walk us through the positive flywheel? And why can Classiq out-innovate its competitors?
So right now what we have that competitors don't are 2 main assets. One is, as I mentioned, an outstanding team with a real DNA for building a quantum software company, which is rare to the point of non-existent in other companies. And second is already a large user base and a strong brand. So we already have these dozens of customers. So we know when we listen to the market, we hear it much more clearly. Because it's not reading it's not opening online and seeing what this head of innovation has to say. It's working with the customers, hearing their feedback day to day, 20 enterprise customers and hundreds of universities and thousands of community users engaging with us all the time. So we are inside the market. We know how to listen. We have the quantum software company DNA. And this is the flywheel effect, because this is something that is, this enables us to build a better product and get to more users and then listen even more closely and better and then build an even better product. And by the time someone else gets this number of customers, hopefully we will be 10x from now. So this advantage is a big one.
Maybe to wrap it up, for investors, why should investors pay attention and invest and look at Classiq? Can you give maybe a 1 or 2 minute summary?
Yes, it is because you don't have a lot of opportunities to invest in the next Google, NVIDIA, Microsoft. It doesn't come a lot. These revolutions in computing happen every few decades. And quantum, I would argue, is not one of the small ones. It's maybe the largest one yet. And here I can say a lot of risk factors why we will not succeed. But if we succeed, and we are devoted to doing so, then we will become $1 trillion company, as simple as that. We will become a category leader in the largest category there is. If you believe in quantum computing, this is a very good way in order to get a very, very large multiple on your money if this industry evolves in the next 10 years. So it's relatively high risk maybe compared to, a small a SaaS company with a already existing market. But I think when you do the kind of risk-reward analysis, there is a very high reward here that may be worth taking the risk for.